I'm Gaurav. I work as an engineer in the mobile team at Myntra. So we've been using React Native for last 2 years, and having started early, we have learned along the way. And I'm here to share our learnings with all of you. So I have a lot of content to cover in this next 30-35 minutes. So let's get started. To start off with, where are we with React Native? So let's start off with where we stand in React Native currently. So more than 80% of our iOS and 60% of our Android apps are currently written in React Native now, who have been moved to React Native. And of the code that has been moved to React Native, 95% of that code is shared across both iOS and Android, given that we have written all of it in JavaScript. Then any new feature that comes up, now we build that in React Native only, so that we can target the already existing app versions that are already installed on users' devices. For example, Myntra shopping groups. There was this construct, Myntra shopping groups, which we wanted to introduce to users. One way was to do it natively, independently on Android and iOS, and release new app. Wait. Since we did it on React Native, we managed to bundle it across and push over-the-air bundle updates to our last 2 or 3 app versions on Android and iOS without the user having to update their app via the Play Store. So this is the benefit that we reaped, and we didn't have to push any APK or IPA update on the store to get this feature out. Now, what exactly is React Native? I'll only briefly go over this. React Native lets you build apps using only JavaScript. So that means instead of learning Objective-C and Swift and Java and Kotlin nowadays independently, you can just learn JavaScript and you can develop on both Android and iOS. Now React has been designed in such a way that it's native, meaning that the underlying components that it uses, they are still native. It's just that it's a wrapper on top. And it is declarative. Declarative meaning you just specify how your UI should look, and the bindings, like what events and all the interactions, and React handles it. React takes care of the underlying details. In that sense, it's a declarative framework. And it's developer friendly. You just have to learn JavaScript, and you can deploy on both Android and iOS. For example, I now own the homepage of Myntra on both Android and iOS. And when I started working on the homepage, I only knew Android and some JavaScript. But without even knowing iOS, I now own that entire homepage feature of our iOS app. So that's the power that it gives you. Now I'll just briefly go over this basic render flow just so you guys are on track with this. Generally what happens in native is you have an XML or a storyboard that gets mapped into a native view hierarchy of view objects or views, and they eventually get rendered on screen. In React, there are 2 more steps to it. You write your UI in JSX, similar to the way you declare it in your XML files. JSX is very much similar to XML. That gets converted into a tree of JavaScript objects, and those objects are of type React component. That entire tree then gets transferred to your native view objects, group views and all. And the way this tree gets transferred to your native is via the JavaScript bridge. So this is the only way to communicate between your native thread and the JavaScript engine, back and forth. Then after that, it's only simple. That native view hierarchy is eventually rendered on the screen. So this is the basic render flow, just a high level detail. Then the benefits are saved build times. Now the developer, every time you make a small change or a big change, you just have to save that file, and it will automatically start reflecting on your emulator or your phone. You don't have to press that build button and the entire APK or IPA file just gets generated and installed on your emulator, and then you finally get to see your changes. You save your file and it automatically refreshes on your emulator, just like on web. This HMR stands for hot module reloading. So the next time when you save your file, it only modifies that particular file and loads up that bundle pretty fast. Then there are over-the-air bundle updates, as I explained with our Myntra shopping groups feature, one example, where you don't have to push your users to install the latest version of the app. You can just push your JavaScript bundle, your entire bundled JavaScript code over the air to the past app versions that are already existing installed on the user's devices, and they get the latest update, the latest code, and all the bug fixes and all that. And faster productization and even faster bug fixes that I explained because of the over-the-air bundle updates. If there is a bug that is being reported in the last 2 versions, then you can just push a bug fix, push a new bundle over the air to those app versions, and it'll fix it. There's no need for them to update the app to have a fix. Then cross-platform code sharing. As I mentioned, whatever code that has been moved to React Native, 95% of that is shared across iOS and Android. So you get this for free since you're writing in JavaScript. Then you have saved costs. As I explained, I now share the responsibility of owning the home page on both iOS and Android. And when I started, I didn't even know iOS. So you don't even have to actually have separate devs on same feature working on different platforms. You can have the same dev working for web, iOS, and so this was just the introduction. The main part of the talk is about the challenges and learnings that we face, the challenges that we face and the learnings that we reaped out. So first challenge was to organize our repos. So us being the early adopters of React Native, it initially released for iOS, React Native. So we weren't sure whether to use it, to what extent to use it or not. So this was just an experimental thing for us when it launched initially. It's like back 2 or 2.5 years. So then what we did was, in our Myntra repo, we just created this another directory called JS, and all our JavaScript code specific to React resided in this JS folder. Then 6 months later, React Native launched for Android as well, and we followed a similar structure. There also, again, we had this JavaScript folder inside our Myntra Android repo, and it contained all our JavaScript code. And we started moving those screens, whichever screens which we had moved in iOS to React Native, and we started moving those screens in Android as well. But since this was an experiment, the code wasn't that well written in iOS. We just wanted to get it out and get early feedback. While working on Android, the code was a little more well written. So now you see there is a discrepancy between the two. And React Native solves this problem because it says that there should be code sharing. But the problem with this is we are not sharing our code. There are independent JavaScript folders residing on our independent repos. What React Native recommends is this approach. You have your single repo where you have your Android folder which contains all your Android code. Then there is iOS folder which contains all your iOS code, and SRC or JS folder, whatever, that contains all your JavaScript code. But ours being a relatively big team and having worked independently on Android and iOS, having separate repos, we just couldn't merge those 2 repos into a single one just because of React Native. So here, what to do? So what we eventually did was, we didn't merge our 2 repos of iOS and Android, we kept them independent. But we created this new repo called Backbit. Now this follows that same structure. There is an Android folder which contains Android specific code, iOS, and then source. But these Android and iOS folders don't actually contain the entire Myntra source code of Android and the entire source code of Myntra in iOS. It only contains the native dependencies that are required for Backbit's JavaScript files to function. That's it. Our main code still resides in our Android and iOS repos. So now this is a separate repo that exists. Now how do we link it to our Android and iOS repos? So our iOS and Android repos contain a package.json file. There we just specify our rn backbuild as a dependency. Now this dependency, if you see, this is the way you specify a GitHub repo as a npm module. So here we have specified that you should fetch this module from this address, and this v1.7.0 is just the version of that backbuild that you want to do. So now when you do npm install on any of your Android and iOS repo, inside node modules, an exact replica of this would get downloaded. Now that would be for your entire structure, entire RN-BAT build folder. How do you link your Android Java code that is residing there with your Android actual Android developer? That's pretty simple. I think all Android developers here know that. In settings.gradle, you just specify include that project and you link it with your RN-BAT builds Android folder. And similarly for iOS, you link it like this. In pod, you specify that there's a dependency called BAT build, and you specify the path, node modules, RN-BAT build iOS, which is that. Here also, I couldn't get the entire thing here, but the path was similar. Node modules, RN-BAT build, and so it's now linked with your BAT build. So that's how now we have organized our repos. So the other challenge was managing heavy computational tasks. So before I get into that, I'll just again give a brief overview of this. There is a JavaScript engine runtime which is running all your React Native code which is in JavaScript. And there is your main thread in native which is handling all the native stuff. And then there is a JavaScript bridge which is handling the traffic, the back and forth communication between the JavaScript engine and the main thread. And this is how the traffic on this means there is a message from JavaScript thread to native thread that do this. And then if you see end2.js, that is the exact log. And these logs, the way I have fetched it is in the Android log file. These are not by default enabled. You will have to enable a spy mode, which is not exactly documented by Facebook. I found it hard. And as soon as you enable that spy mode, a plethora of these logs would start coming in your log. That is just for debugging purposes. Never enable it on prod or even debug mode because it slows down. So yeah, the problem now. So the problem is JavaScript is single threaded and there is no planned support for web workers, which is in simple terms is to spawn new threads on your JavaScript, spawn multiple services in separate threads. So what to do if you have a, so this is one example. What was happening was our screen transitions during development mode. I just came the next day and I saw that our screen transitions are taking around 6 seconds. And I was like, why is the screen going from one screen to another is taking 6 seconds? So that's how I got to know about this message queue. That then I went through all of these logs as to what is going on. So if you see here, there's a difference of 6 seconds or even 7 seconds between. So your JavaScript thread is actually stuck on that instruction for 6 seconds before executing something else. So the reason why this was happening was because of a buggy code someone committed, and what it was doing was it was creating like hundreds of copies of a JavaScript object, which was obviously inefficient. So that was because of a bug, but generally if you want to compute any heavy computational task, don't do that on a JavaScript thread, pass it on to native. So that's on my next slide. Yeah, so any heavy computational task, what you have to do is pass it on to native, that these are the arguments, you compute this entire thing and then pass me back the result. The way you do it is via native modules. Now what are native modules? So if you see here, RK timing and RCT event emitter, these are actually native modules. You can consider them as native modules. There is a corresponding RCT event emitter.java file existing, and it contains a receive touches method. From your JavaScript, this native module construct, what it provides is you can call your Java classes methods if they are extending a native module. So in JavaScript, I called this method. Suppose I am taking this example, rku.imanager.setJS response. So it will eventually call your Java's same name method. So these are native modules where you can pass some arguments to over your JavaScript bridge to the native module, and it will execute the whatever you wanted to execute. So that's how you have offloaded your JavaScript computations to your native thread. This is when I'm heavy computations. By that I mean somewhere in the order of seconds, like 1 or 2 or even 6, 7 seconds. For moderate computation tasks, which are somewhere around 200 or 300 milliseconds, there is a construct that Facebook provides, which is interaction management. So what it does is, suppose the user is scrolling and there is some active interaction going on, or there's an active animation going on. and you don't want to do some heavy computation at that point and block the UI. So what this function does is, whatever piece of code you pass into this function, that is executed as soon as any animation or scroll or any interaction that is going on, as soon as that finishes. So it doesn't block your UI, and it gives you a good experience. So for moderate around 200 to 300 millisecond computations, you can use this. And of course, if you still find your app slow sometimes, that why is it slow, it's not responding and all, you can enable your spy mode again and see the log and see if you are doing more than is necessary on your JavaScript page. The another problem was initial screen load time on Android. Again, I'll go through a brief history here. In iOS, all your JavaScript code is run in JavaScript core engine, which is already initialized by the operating system. Any web view that your apps use, UI web view on iOS, they internally use Safari, and Safari runs your JavaScript in that JSC engine, which is initialized by the OS. So there is no initialization overhead involved. Similarly, so for our Myntra app, you can do the same thing. So our app, the bundle that is there, the JavaScript bundle, that also utilizes the same JavaScript core engine, and it runs the JavaScript. So there is no as such delay on iOS because the engine is already initialized. But on Android uses a Chrome V8 engine, which is initialized by the OS, and it's not always this Chrome V8 engine that is there. Chances are, because of the fragmentation in Android, there is some stock Android that is there, and that is not using this engine. Due to this reason, Facebook decided to still stick with the JavaScript core engine that they had with iOS. So in Android, generally, if you open a web view, it uses your Chrome instance, and Chrome internally runs your JavaScript in Chrome V8. But when we want to run our JavaScript code, the JS bundle code, Facebook decided to go with JavaScript core engine only because it was tried and tested. So now what happens is, if you use React Native in your app, this JavaScript core engine is bundled with your app, and that increases the app size by around 2 MB. So what we actually did was to offset that 2 MB. We did API splits and removed some of the unused resources and some locales and all. So eventually the net increase was around 100 or 200 KB. So it uses this JavaScript engine in Android. So our app loads that engine and then loads our bundle onto it, and then it starts executing. So this is the step. This is the splash screen that shows up, and when this is showing up, multiple initializations are happening in the background, right? Some like Facebook SDK initialization, crashlytics and all that. In parallel, there is an async task going on, which is initializing the JavaScript engine runtime, which is JSC, which got packaged with the app. This takes 400 milliseconds on low-end devices. And then after this engine is warmed up, then you load your bundle onto this engine, and depending on your bundle size and the kind of device, the execution time depends on that. So we tried this on a Samsung Ace device, or I don't exactly remember, but it just had gotten its update to API 16, and that was its final update. So it was a pretty low-end device. And there, to run this app, there was an additional overhead of 1 second on the initialization front of the app. So we decided whether to take this call or not. So we compared it with state-of-the-art apps that already exist on that phone, and startup time was still comparable. So we went ahead with this. So now what to do about it? You can't do anything about the first part because JavaScript core is the one that Facebook is using. So it has to be packaged, and you have to make use of that. But the second part you can optimize, that the loading of bundle onto the engine. Our bundle is a significantly sized bundle because, well, 60% of our Android is on React Native, and the gzip version is somewhere around 600 KB. So loading of that much of code onto engine takes time. So I'll discuss what we are doing for this after some slides. So just hold that. this was for me to take. So another challenge was the navigation part. So React Native assumes that your entire app is in React. So, and the solutions that existed out there in the open source community was assuming that your entire app is built from scratch in React. But that is not the case. Ours being a hybrid app by Rn plus Np, some things in React Native and some. In that case, this is one of the stack that can be created. React screen, then a native screen, then a React screen, then a React screen. So here, if I were to use the open source solutions that already existed there, the JavaScript based solutions, which are, for example, React navigation by Facebook, X navigation by Expo, and React Router, all JS based. What will happen is the front stack would still be fine, but when you press back, React to React transitions would be fine, but as soon as you make another back transition, it will miss the native because it's fully maintaining only the JavaScript stack. First of all, it's really difficult to actually use it in a hybrid app because there are native screens involved. So the back stack maintenance is a difficulty, real difficulty. So that's why we didn't go with any of those solutions back then. So what we eventually instead did was wrap each of the React screen in its own React activity or a view controller. Native screens themselves have a view controller or corresponding activity. So with that, the OS is now maintaining your backstack. As soon as you press back, since these are activities only on top of each other, the backstack is maintained and the entire logic is fine. But can we do better than this? So here the problem is this. For two React screens, you are wrapping each of them in their own React activities, which is kind of an overhead. You could have a single React activity where you can have these two React screens and maintain that at least this small stack in your JavaScript, right? So for this, there is now a new existing solution which is React Native Navigation by Wix, and there's another native navigation, a solution by the name of Native Navigation by Airbnb that is still in beta, so we are going with React Native Navigation by Wix. So what this does is it handles this problem. So now the entire stack of React screens, they are maintained in a single React app. And all of these independent screens are the children in that XML in a relative layout or frame layout, and they just keep maintain the stack. And they've done it pretty efficiently, so it's pretty fast. Now, bundle updates on already installed apps. How do we do it? Okay. Suppose this is your native apps dev branch, your Android and iOS repos dev branch. And in January, you released your app whose app version was 1.1.0. Then in February, you again made another release with the app version 1.2.0. And then you found there is a major bug that is being reported by the users. Now what do? In both of these app versions, that major bug is being reported. The only thing you can do is in the March release, you fix it. And you ask your users to please update your app, and only then you get the fix, otherwise it will keep crashing. In the React Native world, you actually fix it for that release, but along with that, you have the facility to push a fix for 1.1.0 as well as 1.2. So that's one of the real big benefits of React. Now, how do we do it? Again, going through the same structure here. There is a native development branch that is going on. In January, you release this app version. So what we do is, with every app version that we release to external users, there is a JavaScript bundle that we package with the app. And the way we name that JavaScript bundle is like JS bundle followed by the app version. That is the bundle name of the that is the name of that bundle. And the version always starts with 1.0.0, the one that got packaged with the app. So why do we have this name and this version? What happens, the logic that we have written is, as soon as the app opens, the user checks this JS bundle name, which is JS bundle -1.1.0. As soon as the user who has this version of the app, he opens the app, he makes an API call, checks whether there is a new bundle version available for this name. If it is, it downloads that new version. That's how. So suppose this happened, and then in February again you release and you name that version as JS bundle 1.2.0, following the same convention. That is 1.2.0 goes there. And again, since it's the packaged version, the bundle version is again starting with 1.0. Now a major bug arrives. Now how do you fix it? You check out to your 1.1.0 branch, which is the release branch for that particular sprint. There you first fix the bug, then you generate a new bundle, and the bundle, and you increment the bundle version, and then you publish this to your external users. And similarly then you check out to your 1.2.0 app version branch, and there again you generate a new bundle, increment your bundle version, and publish it to external users. So now the next time when user opens the app, he checks for this particular bundle name, is there any new version available? There is. It automatically gets downloaded. And when the next time he opens the app, that new bundle version is taken up instead of the packaged one. And this can go on. You can keep on giving multiple bundle updates. So this is all fine if your entire code resided in as I mentioned, the recommended structure is the Android, iOS, and your JavaScript code all reside in the same repo. But as I earlier mentioned, we have this bad built third-party dependency where our React Native code resides. So earlier when I said that you fix the bug and you generate a new bundle, where are you fixing that? That I'll explain in this slide. So these native repos has a dev and this branching structure with release branch being 1.1.0 for Jan and dev 1.0. Bad build also has a dev. And whenever you are releasing for a particular release version for January, which is app version 1.1.0, you cut out another branch from bad build also, release branch, which is 1.1.0, according in the same name convention as the app. So now you have this release branch, which is again in sync with your native repo. Now there is a major bug that gets reported. So what you do is you first check out to your dev branch of bad build, you fix that bug. This green line shows that those list of commits where using which you fix this bug. Then you cherry pick or you raise another PR to this 1.1.0 branch as well, the release branch. You cherry pick these same changes there and on 1.2.0. And then this being a branch, here you tag it with a new version of bad build, which is 1.1. You just increment the patch version from 0 to 1.0. So now you have a new version of bad build there. So when you are now that you have this new app version, new bad builds version, you just point to this new version of bad build while generating your bundle in your native repos, and it will pick up the latest code till that commit till that tag, and that's how it gets the fix while generating. I'll give you one example. Suppose you are on your native repo and you are initially on your dev branch. On your dev branch, the package.json would look something like this. Ignore the name and version. You're pointing to rn bad builds dev branch. That's how you point. You give the branch name and it downloads that branch's code. Now you want to fix a bug on your release branch, which is 1.1.0. So you check out your 1.1.0 release branch, and there the existing package.json looks something like this. Your JS bundle is JS bundle -1.1.0. Version is the one that got packaged with the app, which is 1.0.0. And rn bad build is pointing to that release branch that we created from there, which is again named the same as the app version, which is 1.1. But now, as I showed you earlier, once you fixed that bug, you created a new tag and incremented that 0 to 1, right? So all you have to do now in your native repo is you update that to 1.1.1 tag. So again, whatever you specify after this hashtag, this can be a commit ID, this can be a git tag, this can be a branch, and it downloads that entire thing into your notebooks. So what you did was you updated that dependency of bad build version to 1.1.1, and then you incremented your version of the bundle so that the user can see, okay, there is a new bundle available. You generated this bundle and then you published it. So next time now the when user opens, it's fixed. So these are few guidelines that we follow. We first, for every new bundle update, we first target our internal audience, all the @myntra.com IDs for a day or two, and once there is no bug access reported by them, then we do a percentage rollout to our external users, 5, 10, 20, using the bucket logic that we have, for example. And we generally support at most last 3 Android versions and last 2 iOS versions, because on iOS people update their apps less frequently compared to iOS. That's why 3 for Android. And we ensure that any new feature, since it is being written in React Native, we ensure that it's released for both iOS and Android simultaneously. Now another challenge was product requirements. So we had to manage our own product managers. So because of their ever-changing requirements, and now they knew that we had this power to do over-the-air bundle updates, they always came up with their small experiments to do this and that, and let's do A/B testing, multiple different experiments. And then you have the UX designers, they want to show a different color to a certain set of users and different color to some other set, and it's really difficult to say no to them. So yeah, accommodating their ever-evolving experiments and UX changes and managing all of that was getting really difficult for us developers. So what we initially did was push back a little. So that was our manager, he was like calm, but we were frustrated, so we just tried to push them back. But those are product managers. Their resume has this big thing written that we get things done. So this didn't last long. So eventually this happened. So our product manager wins and we are there left driven. So they went to our managers and all that. So we had to eventually accommodate all of their experiments. And so what are our future plans? Move the rest of the app to React Native. So the ideal state would be that we have a single React activity or a React view controller which handles your entire app. And if there are web view, we handle our checkout in web view. So there's a web view activity. So ideal state would be this. And another ideal state, another level would be to never push an app up via the Play Store. But that is a long process. Another thing was to divide our bundles into core and feature bundles. So earlier I mentioned that the second part where the load of bundle onto your JavaScript engine, we could optimize on that. This is the part where I said that I'll link it later. So we can divide our bundle into core and feature bundles, and the first time when the app is loading up, to save on time, we can only load that feature bundle that is required for the home screen. So this is one of the approaches. And to optimize your over-the-air bundle updates, what we'll do is the one that is packaged with the app and the one that we want to push, we'll do a diffing between them using an algorithm called BSDiff. And we'll only pass that diff over the air. And that diff comes to be somewhere around 1 or 2 kbs. We are working on this. And only that 1 or 2 kbs gets downloaded and it patches on the app itself with the package version, and it reduces a lot on your data consumption. Future of RN landscape, you have React Fiber, which is a complete rewrite of the React framework from ground up by Facebook, from their learnings over the past 3 or 4 years, or more than that, because they have been using it internally for quite some time. So what they have now done is, the eventual result is faster animations and faster UI updates. So it's pretty cool now. It started from React Native version of 0.46 onwards, 0.45 or 0.46 onwards. Then there is React VR. Imagine currently there was a news that you have ARKit that got released for iOS and AR4 that got released for Android. Suppose you can wrap it all up into a React Native framework and use that instead of working with the inner workings of each of those libraries. It doesn't support it yet because these libraries themselves just got launched recently, but it may support in the future. Then there's React XP. What it tries to do is you write same code in JavaScript, and that is you write same code in JavaScript, and that works even on web, not just Android and iOS. Then there is another thing that Facebook has released, which is end-to-end alternative to REST-based implementations. GraphQL is a much optimized way in comparison to REST-based implementations, and React and Relay are the client side support for GraphQL. I won't go into much details. And there's an ever-growing and active community for React Native that you can very well witness if you go through your Stack Overflow surveys and all of that. React is always on top. And more companies are now using it. Instagram, Facebook, Amazon, Walmart, Flipkart, and many companies. Facebook, obviously. Yeah. So just conclusion. This I already discussed. Cross-platform code sharing, over-the-air updates, dev experience is awesome. And now we can call ourselves just as mobile developers. There is no Android developer, iOS developer, or web developer. We are all mobile developers, and we can even develop on web. And well, React Native and PWAs are, I believe, are one of the best things to happen in recent years in the mobile world, and they have a lot of scope. And the future is cross-platform. Thank you.
Questions?
Were they already familiar with JavaScript before?
Some were. So you just actually in engineering you always have to be willing to learn, right? So in Android, so we had independent teams. Some people were very much comfortable with Java and some were with Objective-C and so on. So we generally took sessions and all for JavaScript. We had some really good web developers who were willing to teach us. So that's how we moved our core developers of Java and Objective-C. It's not that difficult. JavaScript is a very simple. It didn't take much time for them to get it. And once they did, they just loved the developer experience that comes with it. That's it.
Okay, so I started React Native 2 years back. So my question is, when do we have design patterns and it was very messy, telling it to start. So what kind of design patterns do you use React Native? How can we transfer data or add key value observers?
Key value observers, there are multiple ways. So JavaScript supports JSON, which itself is a key value, and for events that you mentioned, there are multiple open source libraries and Node. Since this entire thing runs in a Node environment, there's an events package that comes with Node. So you can use that, or you can use Rx for hooking onto your event publisher subscriber. No, we have our in-house. So when we started with React Native, which was 2 years back, so we developed our own from scratch, and that actually has more features than Code because it is like specific to our needs. It has A/B testing, buckets, log feeding. Log feed meaning you target your internal feed, Myntra.com, IDs. So it's much evolved.
Art experiences are those also on React Native?
No, those are still in.
Do you plan to move them to?
Because
you want to support just a few number of versions. Let's say if you move your card checkout to React Native, you wouldn't be able to just support last 3 versions of the version.
So the reasons are different. The reason why we kept our card in a web view was, first of all, there are multiple payment providers, and if you keep everything in native, you have to install all of their SDKs and all, which increases your output. Right? And then we have done a bunch of optimizations on WebView. Last year, I think we talked about that also. So even the WebView experience is pretty fast there. And that's it. The SDKs that come with the payment SDKs and all this, they just increase your app state. So that's why we've kept it in. And those reviews are actually implemented in React.
Question.
So as I mentioned earlier, when Android and iOS repos, while in that organizing our repo structure, then we weren't using readers. But when we moved our code to Batchbridge, a singular repo, code sharing, there we used all of these state-of-the-art libraries, immutable readers. Navigation, as I mentioned, that we are still wrapping all of our React things, each of our React things in their own instance of React application. So navigation is handled by that. And the way you trigger a new opening of a new activity or a view controller is using a native module that we have exposed, where you just call navigator module dot switch to this screen. It internally handles it.
Yeah. So when the package is updated, so it takes a lot of time to load the app. Usually, you show some progress bar.
Yeah, there is a progress bar.
So it takes a lot of time when you just bundle is updated.
No, bundle is updated in the background. It's not like there's a blocking thing that's happening and it's blocking your UI. So as soon as the user opens the app, he checks this if there is a new version available for this bundle name. If it is there, there's an async task in the background which is downloading it or a dispatch separate. It happens on a separate thread. The next time when the user opens the app, that new bundle is taken.
You mentioned 95% of the code was
So sometimes what happens is there are some inherent differences between iOS and Android platforms. In iOS, the alert shows up like this. There's a toast which is separate. So if you want to show a toast module which is only specific to Android, you have to implement a toast module and a wrapper class for this. There is no equivalent in iOS. So this code is not shared. Similarly, if you have an alert module and you want to show that alert pop-up, there is no equivalent in Android. So for these kind of things, we have separate code, separate JavaScript wrappers. So and stylings also. So there's a platform module that is exposed by React Native, where for iOS our designers want some different styles for some components, and for Android they look a little different. So in those cases, we have to use this platform module. That is, the platform is iOS, use these styles, and the platform is Android, use these styles. That's where that 5%. Overall, the business logic and mostly even the UI are pretty much similar. So that's where 95%.
One last question.
If you see in Android, we have different resource codes like or different basically like different types of events.
Yeah.
But when you go to iOS, there will be three sizes: 2x, 3x. So how to manage that?
So this is internally handled by React Native. As I mentioned, React Native is a declarative platform. So here in Android you have HDPI, MPPI, XMPPI, right? But the name remains the same. So in React Native, in your JavaScript, you just specify that name. React Native itself decides which one to pick up, be it on Android or on iOS. You just specify the name. It decides for iOS whether to pick up the 1x or 2x or 3x. And similarly for Android, it decides to pick up the HDPI or MPPI.
If you see Android, there are different density of device comes up. Like in iOS, you will find hardly 6 to 7 types of.
Yeah.
In iOS, in Android, there are like different densities. So how it will get managed? How many images you have to put like?
So those images, that is up to you as to what kind of resolutions and all of that you want to put into your resources, right?
Which is like high density images are
Sorry to have to cut you. We take this conversation offline. We will start the next one.
Alright, let's discuss this one. Me and my entire team have